Hi everyone, and you're all very welcome to today's webinar. My name is Martin O'Gara. We're here today to show you some of what you've got to look forward to in our MasterSeries 2015 version. Yes, we've been working very hard on MasterSeries 2015. We are anticipating to be able to offer it to you as to try as a beta version within the next few days, and to be able then to roll that out to you all before the end of the month. So what have you got to look forward to? If I just increment my slide here. So in MasterSeries 2015, we have a long-awaited user feature that you guys have asked for quite some time, and that's Windows File Association, whereby you have proper linkage between your files and your Windows Explorer and the MasterSeries. So you can simply double-click on any one of the MasterSeries data files or even associated results files, and those will open up the MasterSeries and go straight into the appropriate program. So if you're working on connections or on masonry or something like that, you don't necessarily have to open up the MasterSeries first and then go into the program and browse to the file. You can just get that instantly, and we'll just show you that in a moment. We're hitting on some of the highlights of the MasterSeries 2015, and one of the major new things that we've worked on this year is our MasterKey connections. It's experienced a major interface update, whereby, and you'll see this, whereby we've done a lot of internal refactoring and working in the software to be able to offer a much richer and more extensible user interface going forward into the future. So that's really very exciting. MasterFrame itself has received a really great new tool for automatic load case generation. You may say, well, we had something like that in the past, but this is much more all-encompassing, and certainly something that's available to all MasterFrame users and not just 3D Model Manager users. And it's got a great degree of intelligence as well, as we'll see. A new feature that really has generated a bit of excitement among the community of MasterFrame dynamic analysis users is our brand new solver, which we have experienced at the top end of speed increases of up to 100 times faster, and it also uses a lot less memory as well. So for the sorts of analysis times that people were experiencing previously with MasterSeries 2014, we were using best of breed eigenvalue solvers, but there's been some major mathematical breakthroughs on that front in the past few years, which we've been able to take full advantage of. So many of you guys who are involved these days in a lot of floor vibration design, whereby you're analyzing composite floor plates with finite elements that are taking a large degree of analysis time, simply because of the nature of the analysis involved there. You've got a much shorter modal analysis time frame to look forward to there in this version, and we'll be able to show you a little bit of that as well. Revit has experienced quite a significant shift in the way that we are mapping between MasterSeries sections and Revit sections. As you know, Revit represents all its different section properties in its system using something called families. We have aligned how we map between MasterSeries and Revit to do focusing more on the families. I'll maybe contrast that a little bit in terms of what's changed against what was there previously when we come to look at that in detail. MasterPort as well, we're going to be having a little look at. It's got some new options for automated internal pressure calculations, which takes account of size reduction calculations. Also automatic size reduction calculations for the external pressure coefficients. And we've got some nice options for dominant openings there as well, which all serve to automatically calculate those internal and external pressures. We'll perhaps just give you a little bit of a summary. After each major version increment, and the MasterSeries 2014 major version increment came out in April of 2014, and we really classify all the new stuff that we've been able to deliver to you as what we've worked on over the intervening 12-month period. And one of the major new features that you may not have picked on following the MasterSeries 2014 major version release was the Eurocode implementation for moment connections, was released in about June or July 2014. So that was quite a significant body of work which took place during this development year. And we'll see that basically as we're looking at connections, as we will do anyway. Also, a slight side note, we've migrated our dongle technology to more later versions. So simply that has served to simplify the implementation of a network license setup. So that's just something to be mindful of, and we can help you out with any queries you have on that moving forward. So as I say, the beta version should be available to try within the next few days, with full release before the end of April. What I'm going to do at the end of this webinar is just display a little poll whereby we'll give you the opportunity to reply to that poll indicating your desire to become involved in the beta testing program. So you simply will get a link to the MasterSeries 2015 beta version. It has undergone a significant amount of in-house testing where we've compared thousands of lines of code or of output from previous established versions. We have done a large amount of testing, and we're fairly confident at this stage before we even provide that to you. So it's very much a release candidate, even more so than a beta version. So you shouldn't be too worried about registering your interest to use this. We'll call it a release candidate. So I'm going to come out of this here now, and this is our MasterSeries 2015. As I say, the first thing I just want to quickly demonstrate to you is our file association. So this is whereby we might have a directory of MasterSeries data files in Windows Explorer. I'm just going to actually close down the MasterSeries here now, because this may be where you're starting from. The first thing you'll notice is these beautiful icons against all the different varieties of MasterSeries data files. Also, the types of the files are described there as well. So our support guys will love this, because the amount of times they've been sent the wrong file, for example an analysis results file as opposed to the actual data file. If I sort these by name, you'll see what I mean. So I have a set of MasterSeries files, MasterFrame data file, which has an associated analysis results file, a concrete file, and also a joints data file there as well. So quite clearly we can see this is the data file. But if we double click in any one of these files, it will actually open us up into the MasterFrame file. So even if I double click on the analysis results file, that will open up MasterSeries 2015 and open up MasterFrame with that appropriate file. And that's been implemented across the board for all of the different programs for all their separate data files. Okay, so we'll just see this bypassing the front screen of MasterSeries, and once it loads its libraries and everything else that it has to do, it should come straight in to the data file. There we have it. So that was me actually clicking on the analysis results file, and it knew, yes, that there's an associated data file with this, and it's come straight in with that. So that's an excellent new feature there, and one I think you'll look forward to. So really that's all there is to note on that. You're just going to find that hopefully a great time-saving new feature. I want to go forward now and look at the changes that we've made to the MasterSeries 2015 connections program. So MasterSeries 2015 has undergone a significant change, and on the face of it, it will look as if simply we have updated the editing interface of the connections program, but actually it goes much further than that. We have done a lot of internal reworking of our data structures and how we store our data files, and how those data files interface with what we call our calculation internal model. So essentially we have here, and you'll notice there's a change in a file extension. We have an IMJX file, and we also have an IMJ. Now those of you who are pretty sharp will know that the IMJ is the previous version extension of our standalone connections file. The extension basically has changed. The MasterSeries 2015 uses an IMJX extension. So the first thing that you will realize there is that there's no backward compatibility from MasterSeries 2015 files to MasterSeries 2014, but that was generally the case anyway. But it is very clearly the case now, because this actually saves the data files in a totally different way. In fact, it uses modern up-to-date XML technology for saving these data files, which has a number of advantages in its own right, in that it allows us to be much more flexible in the future going forward. If we add new features in a 2016 version, those files will actually be backwards compatible with a 2015 version, simply down to the intelligent nature in which XML data file saving is operated. So that's one of the major advantages there internally. However, if I do take an older file, an IMJ file, it will upgrade that file and take all its features to the new IMJX version. Just like you would get if you were to open up a Word file or something like that, it migrates it. It's going to make a backup of the original file, just adding an underscore BCK to the old IMJ extension. So it will drop off this list, and there we have our 2014 file migrated automatically to 2015. So we can see here immediately the sort of interface change that we're looking at. You probably recall previously the sort of editing interface we had here in Connections, in that we had a fixed format series of input which was usually split up into several different tabs, whereas everything now is represented in this what's called a property grid window, and it's very much an industry standard style editing interface. You'll see this type of interface in AutoCAD, in Revit Structure, and it offers a lot of extensibility to us moving forward, in terms of we've got a very flexible environment in which we can add new features, and we'll see that, and we've done a lot of that already for the migration from 2014 to 2015. A couple of things you'll notice here is we don't necessarily have tabs the way we had previously, but a lot of these properties can be filtered. So we can filter to say just the column properties, or we can filter to say just the beam properties. So you can reduce what you're seeing on the screen. Also lots of other nice options, such as collapse all, so we can just see the main categories, or expand all. Expand all expands absolutely all the little indentations, or we can say collapse all but categories. So straight away we can see here things like section properties are very quick and easy to access, with all the integration with the MasterSeries Steel Sections database automatically imported there. There are lots of extra features that we've been able to deliver through this as well, a couple of which are a nicer way in which to handle load cases. Previously, you may have noticed in the standalone Connections you had 10 fixed loading cases here. You may have only used one or two of them, but there was a drop list of 10 fixed cases, and you couldn't have any more than 10. Whereas now, if you've just got one case, you've just got one case. If you want to add another case, let's pop that in, specify slightly different parameters there, and you now just simply have the two cases. The case can have a title as well, so which is something you couldn't have previously. So I have a dead plus wind case there, and that'll come in nicely in the output also. You previously only had options to print up to two cases, whereas now every single case can be printed. So each of these, when I scroll through these, this is the information for that case, and if I want to print that case, it's simply a matter of saying yes, and or double click there also changes it from no to yes, and you can have up to 6 or 7 or 8 cases printed, or actually all of them if you wish. Another very nice new feature with regard to the print case setting, and it also applies to, for example, in base plates where you've got a fire case switch setting. If, for example, this were an integrated connection with MasterFrame, where you might have lots of loading cases, and you set particular cases that you want to print, then you might have gone back into MasterFrame and deleted lots of cases, or introduced new cases. Previously, you would have had to input the numbers of those cases back in the interface when you came back in, whereas now all of that's tied through, and there's a better degree of linkage between your print case setting as it's saved with the actual loading case in MasterFrame if you are coming from an integrated environment. Now, just working through some of the other new features there, you'll notice that a lot of the environment, you can see quite clearly here the summary of the bolts that are available there, but dropping that down can give us full integration with the bolt library as well. So a lot of stuff which previously may have been controlled by flags or numbers now has proper facility to be able to be controlled. So for example welds, I think previously you simply had a deep fillet penetration size or a weld size, or both. and you had to put in, I think, a 99 for in the partial or deep fillet penetration to specify a full butt weld. But now you've got proper interface to be able to specify that. So if we specify, yes, we've got a full penetration butt weld. In fact, uh, the editing environment is adaptable in that it will not then display other unnecessary parameters to us. So we can see there, as we change that, certain other options are dropping out. Just flicking through this a little more, things like the extended end plate here. Well, actually the 2014 version saw the introduction of more than one bolt row in the extended end plate, just to highlight that new feature to you. So you can have more than one bolt row in the extended end plate for the 2014 version. However, the way in which these gusset plates were previously controlled would have been through the bolt rows. Now let's have a look at the bolt rows in this area. Let's just actually filter just to the beam and not the column. So we have 5 bolt rows, and you have a summary of what's happening at each of the bolt rows there. So for the top bolt row, we would have had to say that there was a gusset plate in the end plate only. Now, if I actually take that out here, oh, that's another thing, you can't have blank values in property grids, so I can specify that there. You see that doesn't actually influence. So this is how the stiffener would have been previously influenced at this bolt row, which a lot of people found maybe a slightly unintuitive way. Whereas if you go down here, you've got a separate section for gusset stiffeners, and you do have a separate input area now for the extended end plate gusset stiffener. And we can see here we've got a top thickness of 10, and we can do things like, let's increase the length of that to 250. In fact, let's increase the top length of it to 100, so that we've got a flat top sloping down. These inputs were available previously, but now it is a lot more nicely categorized, and hopefully for new users of the software, you'll find all of these options a lot easier to access than you did previously. So things like when I flick the columns here now, you go to shear stiffeners. Yes, you've got everything there to do with the shear stiffeners and a proper set of interfaces there as to what actually is going on there. So if I say, for example, I've got a 10mm thick Morris stiffener there, it is going to summarize that to me so I don't necessarily have to drop out these options to be able to see actually what's been specified. You can see a little summary of what's been provided there, and obviously the quick and easy access to change that. So a lot of nice new feature in terms of how that's provided. We'll see as well, if we come back here, there are extra input with regard to the columns in the standalone connection when we're dealing with Eurocode. So if I were to come to the column, and you now have column moment and column axial, which you didn't previously have an input for, and in fact even those are specific inputs to Eurocode design to do with the beta modification factor and the shear modification factor in the column web when checking for shear. However, other things like if we go to 5950, we'll see that these options are grayed out. So it's a very useful tool to be able to adapt this interface so that we know that these actually aren't relevant when dealing with an alternative design code. So a lot of thought has been put into this here, and I think you'll find this very, very useful. As we go forward through to other types of connections, you can see them all coming through. And remember, this has been upgraded from a 2015 or 2014 file just now, and everything is coming through perfectly. If we look, for example, let's open another file here. So we'll say yes to save that. And we've got one that has a few more joints in it. And I just want to come to, say, for example, a circular hollow section. And another example of the adaptability of the interface. You've got bolt details here. Do you want pitch circle diameter bolts? Well, previously you had two separate sets of input, and simply one superseded the other if you specified information in one area, not the other area. Whereas now you can simply say, yes, I have, and you get the appropriate input provided to you there. Very similar thing happens if we go, I think at the end here I've got a column splice, and again in the input previously there was 3 separate sets of areas where you could put in cover plates, end plates, or end plates with web cleats, whereas now we can simply flick between the 3 and the appropriate sets of inputs get displayed depending on which one of those that we want. So it is a lot more simplified in terms of the interface there for that nature of things. And as I say, the results or the analysis or the data file itself is very much saved in a new format, which offers a lot more flexibility for us moving forward. So those are some of the new features there. I no doubt that in the mix of everything that I've missed some things out. Things like in the previous version where you had a cell form beam, if I go for beam sections, when it's an integrated connection design, the cell form depth will come through. So you may have a 457 parent section, but it might have been a cell form section, which would have increased it, say, to something like a 600 deep section. Previously, that wouldn't have come through in the integration, whereas now that will automatically come through with the cell form depth. But in the standalone design, I can specify that cell form depth, and that will come into play there as well. One small point to note is that in the previous editing interface, every single keystroke that you made had an effect on the results, which may not have been something that you always wanted. So it is a case that you type and you hit enter to affect that change or move away to a different cell, which is pretty much standard for this type of editing interface. Great, so I think you got a good flavor there for what we're looking at and the sort of ease of which you can use this new interface. I would estimate, for you guys, that some of you that are very familiar with the existing interface, there's going to be a little transition there for you, but I think very quickly you're going to come to love this new interface and find it just as easy to use. We've worked hard in terms of trying to make it as easy to use as possible by extending the capabilities of the standard interface, like the putting tabbing in if you just want to quickly tab through your inputs and specify values. So all of that will help to speed things up for you. Okay, moving away from this now because time is rolling on, I'm going to go to the next area of new feature, and that's in MasterFrame. And I'm going to have a look at these automated load case generation features in the MasterFrame. Right, let's create a new file actually, and I'll just call it load cases. And just a standard portal frame of some description will do. And proceed with the generation of that. So this is what we got previously in the MasterSeries 2014. You had a few loading cases generated for you. Now you did have options to specify what those loading cases were. Out of the box, MasterFrame simply generally produced 2 loading cases, which is what we have here. A dead plus live and a live load only, simply of this nature. I am working to the Eurocode here, so it is being specified as such. However, you could have extended this list of loading cases and then actually saved them as the default. There were options there to do that. There's options to say, if I can find or remember where that's done, but there are, I think it's when you come out of the editing environment, were options to say save the current set of loading cases as a default for a new file. And that, I suppose, helped a little bit, but it certainly wasn't something that would work for everything. You also have options, and you still have options, to import loading cases from another file. So if you have, some people are diligent enough to set up sets of files with different sets of loading cases, and you can import those cases from another file. We then in the 2015 version, listening to the sorts of features that you guys say you're interested in, we've delivered this automated load case generation. Now if we look at this automated load case generation and just start to tease out how it actually works. To start off with, we have what we call our load case templates list at the top. Now out of the box you'll get some of these standard load case templates given to you. You can extend this list of templates and save it as your default, or you can delete some of them, or you can even actually save them to a file and import them from a file. So there's lots of options as to what this default set of templates looks like. So what is a template? Well, each of these items is a template for a loading case or a set of loading cases that will be generated. Those loading cases will be generated if I choose the select. So yeah, in this case, all of these templates here are going to generate new cases. But for one template, this one I've called dead plus live, so I can rename that to be whatever I want. So this one's dead plus live, and this template specifies down here all the settings of this template are specified down below. So for the template, basically, I have selected to include load groups D0, D1, and L1. And it gives me a nice little description here of what the types of those loads are. But further down, I also then get to say, well, what types of cases I want to be generated. I want ultimate and service cases in this instance. And because I'm in Eurocode, it's giving me options for what type of ultimate cases that I want. And this is something where people have been asking us about for quite some time, in that not everybody wants to generate the most favorable and economical combinations of equations 610 A and B. And that's whereby you've got not the full 1.35 dead with full factored live and or accompanying live versus the options for having full factored dead and having a lesser factor on your accompanying live and wind loads, for instance. So whereas equation 610 simplifies that and says, right, well, it's always 1.35 dead plus 1.5 on your leading live load and then a reduced factor on your subsequent permanent loads. Let's use the right terminology here. Permanent and variable are the terminologies for the dead and live, if you like, in Eurocode speak. So if you don't want that, you can simply say, well, I just want equation 610, but we'll stick to equation 610 A and B. You've got the option here to add the equivalent horizontal notional forces as well with that. And for the service cases, we always previously simply generated the characteristic cases for service, but were of course options in Eurocode 0 for frequent and quasi-permanent sets of cases as well. So we'll stick to the characteristic here. Scrolling down through this, now you've got live load only, dead only. These ones are just service, and dead plus live plus wind. Now we have things coming on board here. Dead plus wind, actually in this case, is interesting because we wanted minimum dead plus wind, which would be 1.0 dead plus probably 1.5 wind in Eurocode factors. So we had to check the options here to say that in this instance these permanent loads were favorable, and we want to generate them for all wind directions as well that we may have specified in our wind load directions. So lots of really good options here for generating all of those. Further down here as well, you've got the options to add to existing cases, update existing cases, or replace existing cases. So if I were to simply say replace existing cases and do a preview, then I can see all the loading cases that are going to be generated, which is really useful before we actually push the button to generate them. And you can see very clearly here the full description of what load groups are included against which load factors. If I wanted, there are nice options here to say include the template name in the load case title. So if I do that preview again, you can see now it has the dead plus live in that load case name to help you as a descriptor. Another really useful feature is that I may have all sorts of dead loads. I might come in here and say, well, I want dead load 2, 3, 4, etc. in this list, but I may not have used dead 2, etc. in this particular model. And that's fine, because we can say we only want to include the used load groups. So I'm checking that box and doing a preview, you can see it hasn't included dead 2, 3, or 4 because there were no loads found on this model in that load group, so it's intelligent enough to know not to do that. However, if you're planning on using these loads and you just want to generate the cases now and you'll be adding these loads at a later stage, then you would uncheck that box and you'll see now the full sets of cases that are going to be generated there. Another very useful facility in this list is to filter this list. So if I wanted to just look at the live it orders the list where the ones that are selected are always at the top, but you can of course click on the headings here and reorder that list in any way that you want. So if I just wanted to look at my A loads, I can see here, let's filter to selected again, I can see the A type load groups coming in, enabling me to quickly and easily select one of those and check it to be included, as opposed to having all the load groups and having to scroll down through a big long list. So this is just a little filter option for this grouping area. A very useful option there as well is if you only want to look at the load groups in this list according to the load groups that you've used in your model against your loads, then you can check that box and you can see here now these are the only sets of load groups that are currently used in loads or supports or anything else in the model currently. So it's a good way to filter down that list to just what's actually in use in your frame. Now coming along to if I want to say generate an additional template, let's add a new template in, and I'm going to call this one accidental, and I'm going to say that this accidental one is dead 1, dead 0 and dead 1. I'm going to include live 1 as well, but I want to include live 2. Now live 2 I'm thinking will be the load group in which I will actually specify the accidental load. The program doesn't know at this stage that live 2 is an accidental load. In fact, we haven't really visited how we specify lots of different things. If you can, I don't have an option or a facility here to show you Eurocode 0, but simply in Eurocode 0 there are lots of psi factors against different types of variable load, and whether the load is for office use or for storage use, and particularly for the frequent and the quasi-permanent cases, those vary quite a lot between the different categories of load. So we need to be able to specify, for example, that the live 2 is an accidental load, but for other types of service cases I might want to be able to specify that, for example, live 3 is a storage type load, for instance, and we'll come to that. But for now I just want to say, how am I going to say that live 2 is an accidental load? Well, first of all, for the type of load case that I'm going to generate, I'm going to say that it's accidental. And if you look at the Eurocode 0, you see you've got options as to whether you want to use psi 1.1 or psi 2.1 for your accidental loads. That's a choice that Eurocode gives you. You have the choice to do that here. So I'm just going to save that here now, preview, and you can see now the accidental coming in, but it's actually using a 0.3 factor against the accidental, that is the default psi 2.1 factor for a non-specified type of variable load, whereas I would expect that to be 1.0 in the Eurocode. Right, so if I close out of this area, and let's go to the load group titles now. So this is where all our load groups are given a name and a title, but in addition to that now we also have the option to say what type of load. So for example, I'm looking at live 1 load group here now. It says L1, and I can specify a table A 1.1 Eurocode 0 load type to any of my load groups. These mostly refer to your variable type load groups. So for instance, I can say that specifically live 1 is a domestic and residential, which won't actually change anything because I think the psi 1.1 factor is 0.7 still in that instance. It would change perhaps something if I were to go down and say that it's storage or some of these other types. However, for my live load 2, I want to say that it is an accidental type of load. And I will also go into my member loading and put on a live load 2 with a value so that it is one of the load groups that I've used in my frame. Okay, so let's go to our live 2, and I probably should have changed the title of that live load as well in the load combinations or the load groups area, so that I could actually see that it was an accidental type load to help me in this area. So let's get back to the load cases. Okay, and back in here and down to my accidental case, and we can see that straight away it's informing us, yes, that L2 is an accidental type case. And if I were to preview those cases again, you can see this time then I've got 1.0 against L2, as is dictated by Eurocode 0 for the accidental type case situation. Furthermore, I didn't actually mean to exit from there. There are other types of Eurocode 0 situations. So if I add another template here and call this equilibrium, or equal, EQ, got my letters and all the wrong way around, equilibrium. And for this equilibrium case, I'm going to say that I want dead 0 and dead 1, and let's just go quickly for live 1. But this time I'm just going to go for ultimate, but the set, and these are all different sets that are dictated in Eurocode 0. The set type that I'm going to use for Eurocode 0 is the EQ set, which is your geotechnical structural equilibrium type of scenario. So with that, and do a preview, you can now see that this is coming in with, and we probably wouldn't want to generate equivalent horizontal forces in those types of cases, but it's coming in now with the 1.1 factor against the dead and the 1.5 against the live, with a little tag against it saying that it is an equilibrium type case. So those are some lovely, lovely options there. Now if I just simply say to include that, also make sure that I only generate the cases for the groups that are used. Let's generate those cases, and we're right back here now, and we can see all of those cases that have been generated. Now another very useful facility of this is that if I were to say, well, I want to now include an extra load in this, say A1 for instance, rather than going in here and saying, okay, well, now I've got to include A1 in here and drop the list and A1 in here and having to augment those loading cases manually, I can simply revisit my load case template area, because the load case template area, yes, it's useful for generating large sets of loading cases in accordance with your specific configurations, but it also has a linkage there. So each of these loading cases knows which load template it originated from, and if I were to go in here and change that template, if I now want to include A1, now I haven't applied an A1 type load, so I am going to have to uncheck this box here to not, otherwise it'll ignore this because I haven't used it anywhere. And for this particular dead plus live set with the A1 now included, I'm going to say I want to update the existing cases and do a preview, and now I can see that everything that's based on the first template there now has an A1 included in it. And that was a quick way for me to introduce a new load group into a large set of load cases there without me having to do it in a manual fashion all through all these different cases. Another very, very useful feature is if I were to go to my live one and say, well, actually it's not domestic residential, which has a psi 1 factor of 0.7, it's actually storage. If you change any of the load categories of any of these types of loads, the load combinations will be automatically adjusted in accordance with that. So if we come back to here, we can see here now that I have a 1.5 factor against L1 and not a 1.5 times 0.7, because the psi 1 factor is now 1 and not 0.7. So that's a very, very useful facility there to have. Okay, I'm just having a quick look at some of the options there. You also have options when you're generating composite cases as to whether you want to generate equation 610A, B, or just equation 610. Also in MasterPort, the user editing interface has a new checkbox to say that you want to just generate equation 610 instead of A and B. So thought a little bit more across the board about how you might want to suppress the previous assumptions of always using equation 610 A and B, but to just use equation 610 in some of those other areas where loading cases are automatically generated also. So that's our automatic load case generation. Time is moving on. I want to visit another area of MasterFrame before moving on and having a look at dynamic, and that is our levels editing area. In our MasterSeries 2014, which I actually have opened up on my other screen here, and I'm just going to bring that across. We have our levels editing area. On this big multi-story frame, the user has specified levels at each of the different Y coordinates in the structure, but the default area loading values are then specified in this nature of grid, and if you have composite construction, which is turned on in this instance, then you have further composite data specified here. Now this did present some issues with regard to when levels were deleted or moved around, so we decided to go for a more of a tied object type of interface there, which hopefully provided greater clarity as well as avoiding certain issues with regard to changing levels and deleting levels and such. So if we go into our area loading defaults here on our MasterSeries 2015, again this will all be migrated and updated from your previous version. You don't have to specify anything. You have now everything specified in a levels list, and everything about that level then is specified in a property grid style window down below. So everything that you previously had in those other grids can now be looked at on a level by level basis, and all the same options are there that you had previously. But however, a very nice new feature is the ability to edit multiple levels at the same time. So if I do just your standard shift click to select a multiple set of levels, obviously we can't change the level name or the Y value in multiple scenarios, so that's grayed out automatically. But if I wanted to change now the dead load in all of those cases to 0.45, that's now done it for all the different levels. So there's multiple level selection facility there and the ability to specify a value for each of those very, very easily. It's a little bit, now in the previous version, you had the option to leave values empty and it would have used the level above's value. The same thing holds true. These values here that might be specified at 0 will actually use the same value as a level above. We're maybe taking under consideration whether we want to continue with that with the facilities we have here. However, you can be a little bit more extensible in that you are flexible in that you can select certain levels and modify them. So I could select all of those levels and then specify a common value for them. There may be coming in the future some option to automatically link one level to another level in terms of its properties and its loads and those types of things, but that's something we're looking at. So that's the direction we're shifting in with regard to that. Now I want to then move on to our dynamic analysis program, and really this is going to be very quick because in essence there's not a lot of change on the face of it with regard to the program itself. Obviously the major body of work is behind the scenes in the new solver that we've implemented. As I say, I got to give credit to a fantastic guy who I don't know personally, but a Professor Alex Polizzi from the University of Massachusetts is the chap responsible for the major breakthrough in recent years with regard to eigen solver analysis technologies. And that's something that's then filtered its way down through to the likes of us guys in subsequent years. So we have here now, let's go for floor vibration. So we've implemented this new solver, and as I say, it has demonstrated to be up to 100 times faster in certain circumstances. The other major benefit is also it's much more memory efficient. So we would always say for people using dynamic analysis that you really must be on a 64-bit PC, because the dynamic analysis is much more memory hungry, and 32-bit PCs, where MasterSeries would run it as a 32-bit application, are limited to 2 gigabytes of address space, which sounds like a lot, but on larger dynamic frames that can indeed be problematic. Whereas in a 64-bit environment, you have practically unlimited memory access to memory there, so which is really what you need when you're dealing with dynamic analysis. But this 2015 version will reduce the need for the amount of the memory required. In fact, this little model here required about 3 times more memory in the 2014 version than it did in the 2015 version with regard to its dynamic analysis overhead. As I say, the interface is the same. You can see in here all the different load groups that are included for mass, and the automated density is included there. That's all the same. Also the same is the option to say I just want to go for a grillage analysis. Now what is different is some of your analysis options here, in that previously, if you remember, you had options for how many frequencies do you want to solve for. Now that was problematic in the sense that, well, you usually started off by sticking your finger in the air and say, well, I want to, let's say in a big FE frame, might want to solve for 1,000 frequencies. And then it would go through the lengthy analysis for you to maybe find out that your maximum frequency that you had captured was below the range of frequencies that you were interested in. So then you had to up that number and start again. Whereas now this solver is much more sensible in that it asks you for a frequency range. Now you might have said, well, I remember seeing a frequency range in the 2014 version. Yes, that's true. But actually that was a bit of a misleading in that it didn't actually save you any computational time, because the frequency range that we had previously actually solved for all the frequencies but just filtered out the list according to the range that you specified. Whereas this solver inherently is looking for frequencies in a particular range, which is much more sensible with regard to the engineering side of things. Because if we, for example, are doing a floor vibration on this here, we have a range of frequencies that we're interested in. That's what we know. We don't know how many frequencies we want, but we do know the range of frequencies that we're interested in. So I might be interested in frequencies within a range of 1 to 25, say, and I don't have to worry about, have I captured enough frequencies? Yes, these are the frequencies that I'm interested in, which will impact in my vibration design, and that's all you need to worry about. So I am actually going to click the button here and go for this analysis. Now I did run this frame on our 2014 version. You might say it's quite small. I wouldn't expect that to take very long. Well, this is a composite, a little extract of a composite floor plate here, which does have the need to utilize finite elements, and you can see there are quite a lot of those finite elements to conform to the shapes that we have here, and with the result that really does drive up the analysis time because of the increased stiffness matrix sizes and numbers of degrees of freedom. Now that took approximately 12 minutes to analyze in the 2013 or 2014 version, whereas I'm anticipating that this will complete. In fact, I was analyzing it earlier and it did it in 33 seconds, whereas now it took 40. So I was getting a little worried there, but no, we're there. So essentially, you could look and say that that's about, in this instance, about 25 times faster or 20 times faster. So not quite up to the 100, but that does vary from model to model. We did have one file which in this on our 2014 version took 36 hours to analyze, and on the 2015 version it was done in 40 minutes. So that's you can see the benefit of that coming into play in this area. So you really are going to get a lot faster turnaround in terms of looking at your vibration design calculations. So it can be a lot more of a iterative design process. If you're working on an iterative design process, something can take a day, which previously would have took several days because of the constant lengthy analysis that you might have had to do after each set of changes. And the results are, you might say, well, how on earth could we achieve the same sets of results and the same sorts of speed? We have done a lot of checking against the previous version's analysis results to this new version, and we're getting very, very high levels of comparison between them, so we have no concerns at all about the accuracy of results in this new environment. Older files will need to be reanalyzed. If you open up an older dynamic analysis file, it will say the results file's out of date, you need to reanalyze it. However, that's not a big issue these days with this faster version. Okay, so taking a slight side step away from MasterFrame, I'm going to look at MasterPort and have a look at some of the new facilities there. Okay, this should do. So going into our MasterPort Plus editing environment, previously we had wind and snow in one tab. Those have been separated out here now because we've got lots of extra options available now with regard to how wind pressures are calculated. First of all, we have the same thing we had previously with regard to our linkage to MasterKey wind analysis, so I'm just going to do that. What we wanted to show you basically was these extra options with regard to the internal pressure calculation, and also extra options when you're dealing with the BS design with regard to size reduction factors on the main portal members. Previously, you would have had options simply to the default options of putting in manually your own figures for internal pressure coefficients and internal suction coefficients, whereas now that can be automated. And the automated option will then allow you to automatically take advantage of the internal volume of the structure. So when we say apply CA, that's the size reduction factor, which is based on the internal volume, which is automatically calculated. You can overwrite the internal volume if you want to do that. So you can see these values are starting to come down now. I can't edit these anymore because they are being automatically determined. But furthermore to that, then we also have options with regard to the dominant openings, which are the other thing which influences the internal pressure coefficients. So if I were to display my wind values here, and I've got north gable, south gable, west and east are my four main sides. But if I were to come to my south gable and say that I've got a dominant opening ratio of 2.5, automatically that it has adjusted these values. Now if we look at, so that means I've got a dominant opening of ratio of 2.5. Now the code determines to you what that is in terms of a ratio. It's the ratio of the size of this opening in this facade versus all the other openings around the structure. So we have here a dominant opening on this gable end, which is the south gable. What that means in terms of wind directions is for wind direction 1, we're going to get an increased internal suction essentially in the building, but not an increased internal pressure because of the orientation of wind with regard to where the opening is. But if we come round and we can see that there, that's now increased from 0.225 to 0.46. And if we come round to wind direction 3, well in this instance we are getting an increased value of internal pressure. And that's calculated from the windward facade and the coefficient of pressure that's on it. So it's all done in accordance with the code of practice there. You can also specify a dominant opening diagonal value, which is like a size reduction factor furthermore on the coefficient of pressure for dominant openings. So for example, if something has say a 10-meter diagonal for a big opening, that's going to change that a little bit more, as we can see there. So we can specify dominant openings in all the four faces if we desire, and we can see that coming into play. Now for wind 1 to wind 4 or wind 5 or wind wind 1 to wind 5, the coefficients of pressure that are displayed here are always the external pressure coefficients, so we know that anyway. That's how it works in the 2014 version. But we can see for P1, which is the external coefficient with internal pressure, let's go for P3. So P3, for instance, is the increased internal pressure you can be seen, or increased internal pressure. So internal pressure combined with external suction produces larger values than we had here previously. Whereas if we look at some of the other directions, for example P1, we can see that we're getting increased values of internal suction, which has a contributing effect on some facades and a decreasing effect on other facades. So all of that's automatically linked through and taken into account. Now, one of the things that we didn't previously take into account with regard to portal frames was the size reduction factor on the main portal members themselves. And that really is, previously in the MasterSeries, when we thought about size reduction factors, we've always thought about bracing members. And that's whereby, for instance, these bracing members here are carrying the wind load on the diagonal of this gable facade. So they might very well qualify for a size reduction factor equal to a wind diagonal, say from this point across to this point. Now, or you could argue that these ones might just be influenced by this portal frame here in itself if you wanted to be a bit more conservative. That's not something that was automatically taken into account in portals, whereas now we can do that. We can apply CA factors for bracing members, and that will automatically generate the extra loading combinations that are required and also apply these into the appropriate wind diagonal groups. But another one that we've introduced, which might not be quite so obvious then, is a new way of thinking about size reduction factors for us, and that is a size reduction factor on the main portal member itself. Now, what that really means is the main portal member itself is large enough, albeit it's a member that's locally loaded by wind and not globally loaded by wind, such as these bracing members are. But it's a member which carries a large enough area of wind that it would potentially be influenced by a size reduction factor. So checking that box will take that into account. That in itself does not constitute additional loading cases being generated, because we are simply locally reducing the wind on these portal members by a size reduction factor on the external pressure coefficient. So it's a slightly different way of looking at size reduction factors on members that are locally loaded by wind as opposed to members which are globally loaded by wind. In fact, we're running out of time now, but in the main master frame editing environment for general frames, where we're dealing with automatic application of wind diagonals, or the definition of wind diagonals as defined by you, the user, you'll notice that in the wind diagonal groupings, we now have the option there for you to specify whether the diagonal group represents the members that are locally loaded by wind or globally loaded by wind, and that will impact on the number of loading cases that are generated and the way in which the load comes locally onto that member if it's a member that's locally loaded by wind. So that's something that influences the master frame general editing area also. Where you're not linked to the MasterKey wind analysis, you do specify things like whether you're in town or in country and the distance to sea, because that influences the CA reduction factor, which is then calculated not by MasterKey wind but just simply by the program itself. Also, we've implemented in MasterPort Plus the Eurocode BB, which is the Eurocode equivalent for Appendix G. We had an implementation of that previously, but a recent SCI publication talked about portal frames, gave us some further guidance on that, and we were happy to proceed then and fully implement Appendix BB checking, which is actually, in some instances, quite a bit more favourable than the old Appendix G implementation that we had there. So that's something that is going to be quite useful. Finally, I just want to draw your attention to the quite radical shift that we've made with regard to our family mapping in the MasterSeries 2015 Revit integration. So I've installed the MasterSeries 2015 Revit integration here on Revit Structure 2015, and you can see now you no longer have the tabs for section mapping or family mapping. Previously, our mapping used two technologies. where we had library type sections, i.e. steel sections that are part of a steel sections library, those mapped entirely based on their name. So for instance, we would have taken this 457191 and been able to find the equivalent name in MasterSeries. Problems then started to arise where a user might turn around and say, well, I've renamed this section to MyUB or Fred or some other summarized name. That made it incompatible then with what was going on in MasterSeries. And to counteract that, we give you this separate section mapping area where you could map this particular name to a known name in the MasterSeries section library for that, and that was for one instance of a section. So we felt for quite some time that mapping sections based on name probably isn't the most flexible way to continue. So we have implemented a brand new family mapping database, which is very much an open system. Everything you see here is what you get with the out of the box database. So quite simply, you've got steel sections, concrete sections, timber sections, and for each of the known section shapes in MasterSeries, you can specify compatible Revit families. So for the I sections in MasterSeries, which are defined using these parameters, we have said, yep, all of these Revit families represent an I section. And you can see even here the Chinese ones coming through, the American ones. So lots of other countries' library systems have been implemented in this area as well. So we're saying here that this is the name of the parameter in Revit, which represents the name of the parameter in MasterSeries. Other complexities which give us a little bit of difficulty were things like the root radius in a Revit family wasn't represented with a root radius, but with a K value, which was actually a root radius plus the flange thickness. So that meant that some parameters in Revit were represented in a different way to they were in MasterSeries, and we had to provide an equation editor to say that, well, the Revit parameter K is built up of R1 plus T, and that's going one way, and going the other way, the MasterSeries parameter R1 is based on the Revit parameters of K minus TF. So that just gives you some indication of how that can be handled where you don't have direct mapping of parameters which are represented in a slightly different way. There's a lot of extra facility here, a lot of extra families are handled that weren't previously handled, and it's also much more robust and much more open system than it was previously. It also works for multiple versions of Revit Structure, so we're dealing with Revit Structure 2014 and 2015 for this technology. The paths, where the paths are left empty, that means that it's simply using the default Revit metric library path, and anything that starts then with a part of a path is an extension on that metric library path. Anything that has a full path basically then knows that it goes into a full path. But you can also use parameters such as in square brackets. For here we have RVTY year, which means that if we're using this in Revit 2015, that will be 2015, and in Revit 2014 it will be 2014. So you don't need separate databases for different year versions of Revit. Also, you can simply go down in this open database and add your own library or your own family with your own parameters here. So it is very extensible, and it is certainly going to be a much more extendable and comprehensive system for Revit family mapping moving forward. Now, to complement the addition of the Revit family mapping for other country sections, we have augmented our available databases of steel sections in MasterSeries to provide for other countries' sections, and particularly we've got separate user section databases now for the American and Chinese sections, as well as additional European sections within the main MasterSeries default steel sections library. So if we go into the open library area here now, we have our default steel sections database, which is OpenLib0. Now we can see, so this is the one that section library that we've been distributing for quite some years. But in addition to that, we also have the European and the British sections in this library. but we have additional European sections for various hollow sections and rectangular hollow sections and circular hollow sections, as well as some of the I sections, the IPNs, the UPEs, etc. A lot of those are new categories in the MasterSeries which have come on board. We have had the IPEs and such for quite a number of years, but they're really from anything from UB1 on down here are an additional sets of European libraries that are part of the default Steel Sections database. For the American and Chinese, they are separated into separate databases. So we actually click on Change Drive here, which really just means browse to another open library file. And we have here the China, in fact South Africa and the US. So if we open a Chinese library, we have here OpenLib China 0 there, CHN 0, which is the Chinese sections. So we can see here all of the different types and basically the sections that are involved there. So all of those are fully there for and will be very much compatible with the Chinese section libraries in Revit structure. Likewise, if we go across to, say for example, US here, these libraries again will be very much compatible with what you're getting in Revit structure for the American type sections. And there's a similar one there for South Africa. So a lot of these were brought on board to provide compatibility for libraries of sections in Revit. So we now have equivalents of those in the MasterSeries Open Library System. If I, for example, drop this down to user database 1, this will now be based not on OpenLib 1 but OpenLib US 1. So the naming of the database simply allows us to have different sets of default plus 1 to 9, but in this instance, because we started off with US 0, it will now be US 1. So that's a way in which we have provided additional countries of and catalogs of steel sections. Work that we've done in Word 2013 increasingly was suffering performance-wise because the technology that we were using, later versions of Word, was basically leaving behind. We've done a lot of work in upgrading our Word technology for Word 2013 and above to use the latest Microsoft technology. So you're going to see some significant speed improvements there with regard to Word exports for Word 2013 plus. So essentially, those are the highlights of our MasterSeries 2015 and some of the features you have to look forward to. I do apologize for running over time. It just remains for me to say thank you for your attendance here today, and we do hope to get this beta version out to you within the next few days, and we really hope you enjoy using your MasterSeries 2015. Thank you very much. Oh yes, one other thing, my colleague has just reminded me, we've had someone working very hard here on an extended range of updated tutorials and manuals. So a lot of the stuff you see in the connections and elsewhere that's new is very much well documented, both in tutorial style and also manual style. So that work will continue and be ongoing.